Hi, my name is TEE YAW and I will start present about project A. So the first objective of this project is the client requires the new pipe to made of laminate composites, and the second objective is the pipe must also deflect lower than 10 mm under the weight of the new pipe. And the third objective is the geometry of the pipe as shown in figure 1 is based on our student number. So based on my student number, the length of pipe that I get is 5000 mm, while the inner diameter of the pipe that I get is 60 mm. So this is the VMAT software. As you can see, this is the new design of pipe that I designed for this project by using VMAT software. So as you can see, I sectioned it into 10 sections, which is 10 elements, consists of 11 nodes. So the length of this new design pipe is 5000 mm with a radius of 30 mm. So as you can see, I've built 3 laminates for this new pipe, and each laminate with a thickness of 5 mm, and each of the laminates is built by different types of material. So after we have done building this new design pipe, we proceed to material selection. For the first laminate, the material that I choose is AISI 4340 steel. It is a chromium alloy steel which widely used in oil and gas industry, and it has high strength, favorable response to heat, and exhibit a good combination of ductility and strength. But for the second laminate, the material that chosen is AISI carbon steel 1025. It is a low medium carbon alloy which offers good machinability and can be normalized into hot and cold work. And for the third laminate, which is also the outer laminate, the AISI carbon steel 304 is the chosen material, as it is a commercially cost-friendly material, and it gives excellent drawing properties and also high corrosion resistance, so that it can give a good protection towards our new pipe. So after we have done building this and confirm all the material that we use, we proceed to constraint. So for constraint, I have pinned both end of this steel pipe, which is node 1 and also node 11. So after constraint is done and all the boundary condition is fixed, we can proceed to the next step, which is analyze the new design pipe. So after the new design pipe is analyzed, it's been analyzed, we can get this result. As we can see, a total of 10 mode, which represent the 10 element in this new pipe. Each mode have its own natural frequency, and I will simulate it one by one. So as you can see, this is the mode 1, the animation of node 1. It moving around the y-axis, up and down y-axis, and this is the simple harmonic motion with it moving with a frequency of 4.184 times 10 to the power of 7 hertz. While for mode 2 and mode 3, they having a same frequency, which is 0.304 hertz, while just moving in a different direction. For mode 2, it moving around, as you can see from this direction, it moving around the z-axis, while for mode 3, it moving around at y-axis. And for mode 4 and mode 5, both of them having a same frequency, which is 1.215 hertz, and but they moving in different axis. For example, mode 4 moving in y-axis. We can see from this direction, it moving y-axis, while for mode 5, it moving in z-axis. So for same to mode 6 and mode 7, having a same frequency with 2.724 hertz, but just moving around different axis. For mode 6, it moving around z-axis, but for mode 7, it moving around the y-axis. Same go to mode 8 and mode 9, having a same frequency with 4.81 hertz, but just different axis. Mode 8 is moving in y-axis, while mode 9 moving in z-axis. So for mode 10, it moving in z-axis with a frequency of 7.4 hertz frequency for its frequency. So after I simulate all the 10 modes of my new pipe, we proceed to discuss about the deflection of the new pipe, which is required by the objective 2. The pipe must also deflected lower than 10 millimeter. So by comparing the real eigenvector for each mode, which is node 1 to node 10, we can see that uh, the real eigenvalue, the real eigenvector is shows that the deflection for each mode. So as you can see, the point ID 1 to 11 means node 1 to node 11, and T1, T2, T3 represent the translation for x, y, z axis, while R1, R2, R3 is represent the rotational for x, y, and z axis respectively. So as we can see, the translation for the mode 1, the number of translation the number of displacement is very low as we can treat it as negligible. So it fulfills that the objective of this project, which is the deflection of the pipe must lower than under than 10 millimeter. So it fulfills this objective. So as you can see, for mode 1, the displacement is very low, and mode 2, mode 3, mode 4, and to mode 10, 8, 9, and 10, which show all these 10 modes shows a very low displacement as we can negligible. So after I have done this simulation, I noticed that the frequency that I get from each mode is a bit nearer to the natural frequency of the new pump, which is 3.33 hertz. So I'm try and error many times to try to fix this problem, as I change the thickness of the laminates, and also the number of laminates, and also the different types of material, but it doesn't work. It doesn't show any significant changes towards my frequency. So based on the logical thinking, and also the prices for coating, I decided to fix my new design pipe in 3 laminates and with a thickness of 5 millimeter. So after I done this project, I learned many in using VMAP software, and thanks to my lecturer for giving me a chance to do this project alone, so that I can learn it well. And that's all from me. Thank you.